Hey guys, welcome back to another video of this assembly tutorial series. And last video we talked about how to write a simple program. We explained how the layout of Code Warrior works, what is the meaning of include derivative, xdef, xref, and how to define variables and constants, and how to write a very simple program. And in this video we're going to show you how to compile and run the program. Now, to compile the program, you want to press this button right here, and it's not actually going to run, or nothing is going to happen except compiling. And if there's an error, it's going to show you some error messages. But if you click this green arrow right here, it's going to compile and run. So it's always better to just hit this arrow. It's basically two steps at once. And this is the main layout of your program. You can't write any code in here, but you can see everything that is going on. Now, it's really extremely important to get familiar with this, because this is how you basically debug and see what's going on, what's happening, why your code is not working or working. In the top left side, we can see the code that we wrote. And if we go a little bit up, if we scroll up a little bit, we can see like a bunch of commands and lines of code that we didn't write, and all of this is from the include derivative. You can see here that the include derivative is not here, but actually everything on top is basically the code warrior is grabbing the library derivative.inc and writing it all in here in our program. Then we can see xdef and xref and everything else in our program that we wrote. After that, we can see the variables and the constants that we defined, and we can also see their values. var1 and var2 have not been initialized with any value, and that's why it's undefined. Top right, we can see another way of looking at our code. So if you look at the first line here, we have move byte 1 to var1. So move byte is written right here, and then we have 0x0001. Now 0x here just means in hex, so this number 0001 is in hex, which is in this case equivalent to decimal. And comma, so this is the same comma that we have here in the instruction var1. So var1, the program is actually assigning the variable var1 into memory, and that's basically memory location number 500 in hex. And it's also extremely important to know what this number is before the move B. This number is in memory. It's where this instruction, the whole line of code that we wrote, is located at. So if we go to C000, and before we do that, actually, let's talk about memory here. Let's actually jump register and procedure, and let's go to memory. Now I'm gonna make it a little bit bigger. So this is the memory that we have in the microcontroller. And if you right click on it and go to address, you can pick which address you want to see the contents of. Now the assembly here is telling us that in address C000 there is an instruction that we wrote, move B, and then all this stuff. So let's go to C000 and see what's going on. Okay, so now we're seeing 18 0C 0011. 18 0C is the same exact thing as move byte. Now move byte is just the word that we know what it means, move a byte, but the program or the computer only knows ones and zeros, right? The code doesn't actually know what if is or for loop or LDAA. It doesn't know any of these things. And so when you write move byte, the code warrior actually translates that into machine code in hex, 18 in hex, and then 0C as well. So 180C is equivalent to move byte. Now we can see after that 0001, and that is basically this number right here, 0001. And after that we can see the 0500, which is, as you can see here in the assembly window, we have this the location of the variable. And then again after that you can see the 180C, which is the same thing here, and that is because we have move byte again. So move byte throughout the program means 180C to the computer. And if you can also translate that to binary and see exactly what the CPU or what the computer is seeing, but there is no need for us to do that. And so basically this is how you read and connect between the assembly and the memory. And the memory is extremely important when trying to debug really hard problems and really hard programs when you're not understanding exactly what's going on in your code. So again, this is the pointer. C000 is basically telling you, hey, this instruction lies in the C000 location in memory. And we can see that here, C000 is pointing at AT0C. Okay, hope that makes sense. Now it's also extremely important to pay attention to the register window. The register window shows us all of the registers and all the accumulators and all of their contents as well. So right now they all don't have any of the values that we assigned them, but the second we start running the program, and we can see that their values are going to change based on what we do in the program. So to run the program, to run the simple code that we wrote, you have two options. You can either pick the green arrow here, and basically what this is going to do is going to run the whole program, all of it, and you're going to only see the final result here, which is very helpful and good to see if your program actually works. But for debugging purposes, we want to pick this one, the second one, the single step. Okay, so the first instruction that we do, what we're expecting to happen is for 1 to be moved to var1. So now when we come down here to the data section, var1 here, instead of saying undefined, we should be able to see 1 once we click on this. Okay, so now we can see 0, but I said that we should be expecting 1. So what happened wrong? Well, because addressing modes are extremely important in assembly, and you need to be careful what you pick as an addressing mode. So move byte 1 to var1, because I didn't write the pawn symbol or the hashtag symbol, what the program is, it's going to memory location 1, and whatever the contents in there is moving it to var1. And because var1 has 0, I'm expecting in memory location 1 to find number 0. Well, let's go to memory, right click, address, and then click on 1. And as you can see here, this is memory location 1, it's highlighted right here, and the value is 0. And this is the same thing that is going to happen with var2. I'm moving what is in memory location 2, and this is the memory location number 2, because this is 0, 1, 2. So memory location number 2 now is 0, and so when I step through this line of code, var2 is also going to be 0. So what we need to do is actually choose the correct addressing mode, which is, since I want a number, like actually number 1, I'm going to be picking the pawn sign here. And this should fix it. This should actually be now moving 1, the number 1, to var1. Let's try this. Now you can see var1 has the value 1, and var2 is going to have the value 2. Now LDAA var1, again, as I said in the previous video, accumulator A now needs to have the contents of var1, and A has CB right now, but once we step through this line of code, A is now equal to 1. Then we're going to add that to A, the value stored in the variable var2, which is going to be 2, so 1 plus 2 should equal to 3. Now we can see that accumulator A has the value 3, and the program and the logic behind it works. And as you saw here, we didn't have the pawn sign at first, but because we understood addressing modes and we understood how to look in memory and in the data window, we were able to identify what the problem is and debug the program and fix the issue. Thank you guys for watching. We're going to end it here, and I'll see you in future tutorials.